METARs are aviation routine weather reports.
The code METAR stands for Meteorological Aerodrome Report. These are coded messages of the actual weather conditions at a stated time and place. METARs are usually issued every half hour during aerodrome operating hours. We shall examine the METAR coding section by section, slowly building up our understanding by using a sample METAR report.
The first group that appears in the METAR is the identification of the type of report. The 4-digit IKO location indicator of the issuing airfield is shown next. In our example, we will use Kidlington, Echo Golf Tango Kilo. The next group is the date and time of the actual weather observation. The first 2 digits represent the date, followed by the time in hours and minutes according to universal time coordinates. Notice, though, that the code Z for Zulu time is used instead of UTC. The observed wind information is shown next. Firstly, the direction of the wind given in degrees true round up or down to the nearest 10 degrees. Next, the wind speed in knots, which is meaned over a 10-minute period. However, if a gust is observed at least 10 knots more than the mean, then a gust figure comes after the meaned wind. This gust figure is preceded by the letter G as shown. The next group may or may not appear depending on the directional variability of the wind. It is shown after the main wind group as indicated here. It signifies the extremes in the direction of the wind during the past 10 minutes. The letter V will appear between these two extremes. If the wind is calm, then this coding is used.
Visibility in the METAR is represented by the next group. In the METAR, the visibility reported is the prevailing visibility and, under certain conditions, the minimum visibility. Up to 10 kilometers visibility is measured in meters. For example, 6,000 means that the prevailing horizontal visibility is 6,000 meters, as measured from the observing point. Once the visibility reaches 10 kilometers or more, the code figure is 9999. Visibility of less than 50 meters is indicated by the code 0000. In some instances, we can also find the runway visibility information. This is known as runway visual range, or RVR. It is only given when either the horizontal visibility or runway visual range is less than 1500 meters. This group starts with the letter R, and then goes on to give the runway in use, followed by the threshold visibility in meters. In our example at Kidlington, let us consider a Met visibility of 1400 meters with an RVR on runway 30 of 1100 meters. If the RVR visibility is more than the maximum reportable value, then code P is used in front of the visibility value. A letter can sometimes come after the RVR visibility to indicate the trend that has been experienced. A U means that the visibility has increased by 100 meters or more in the last 10 minutes. A D that it has decreased in that same time period. And an N that there is no distinct tendency. The next section of the METAR deals with weather groups. This signifies what weather is actually prevailing at or near the aerodrome at the time of the observation. This is a complete table showing you what codes can be used to describe the weather.
The first column shown here represents the intensity or proximity of a weather phenomenon. These are minus, which means light, no qualifier, which means moderate, plus, which means heavy, and lastly, BC, which means in the vicinity, but not at the observing point. The next column adds detail or describes the actual weather phenomena which we will see later. Three of the most common that you are likely to see are BC, which means patches and is frequently used to describe fog, SH, which means showers, and TS, which is thunderstorm. The last three columns represent weather phenomena. We shall now look at each of these columns in turn and explain their usage. The first of these columns considers precipitation. This group is fairly self-explanatory. It contains all the precipitation weather such as drizzle, rain, snow, hail, etc.
The next column looks particularly at those weather phenomena which are classified as obscurations. These include mist, fog, smoke, ash, etc.
The final column contains all other weather phenomena which have not already been included. This group mainly consists of the more unusual weather events that are rarely reported, but are important nonetheless.
This completes the whole table of the weather groups of the METAR. Let's now look at how some of these symbols and letters are used. Let's analyze the code which indicates a heavy shower of rain. We use the following symbols and letters to represent this:
Heavy, shower, of rain. The definition of a thunderstorm occurring at a location is that thunder has been heard within the last 10 minutes. Therefore, just because lightning is seen, it doesn't necessarily mean that there is a thunderstorm at any one place. Whenever a thunderstorm occurs, the letters TS are used. If there is no precipitation, then only those letters will be used. However, if there is precipitation of some kind, another two letters are inserted after the TS. For example, if there is rain observed from the storm, then TSRA will appear. However, hail may be observed, so you may see TSGR or TSGS, GS meaning small hail. Cloud is the next information in the METAR. There are several cloud prefixes which are used to describe the amount of cloud in each layer. We subdivide the cloud coverage into eighths, called octaves. Depending on the cloud coverage, cloud amounts may be classified as few, meaning 1 to 2 eighths of cloud, scattered, meaning 3 to 4 eighths, broken, 5 to 7 eighths, or overcast, meaning complete cloud coverage, 8 eighths. The height of the cloud will follow immediately after the amount. This will appear as a 3-digit height in hundreds of feet. Cloud heights in the METAR are always measured from aerodrome level on QFE. For example, 6 octaves at 1,900 feet would appear as broken at 019.
And 8 octaves at 500 feet will be abbreviated to overcast 005. The only cloud types that are specified in the METAR are the significant convective cloud. These are cumulonimbus and towering cumulus.
Shown here is an overcast layer of cloud but with a convective cumulonimbus cloud at about 2,000 feet above ground level, producing a heavy shower of rain.
If there is no cloud observed at the airfield, then the code SKC, meaning sky clear, is used. If the sky is obscured for reasons other than cloud cover so that the cloud cannot be determined easily, then the code VV is used in place of the cloud information to report the vertical visibility in hundreds of feet. Shown here is an example of obscured sky because of fog. A vertical visibility of 200 feet has been reported. If the vertical visibility cannot be assessed, then 3 forward slashes will replace the numbers, as shown here. The term CAV-OK is frequently used in the METAR code to denote that cloud ceiling and visibility are OK. If CAV-OK is used, it will replace the visibility, RVR, weather and cloud groups. There are 4 criteria which must be met in order for CAV-OK to be used. The first of these is that visibility must be 10 kilometers or more. Next, the lowest cloud ceiling must be no lower than either 5,000 feet or the highest minimum sector altitude, whichever is the greater. No cumulonimbus must be present, and there must be no significant weather.
If these criteria are met, then the abbreviation CAV-OK will appear in the METAR code. The temperature and dew point will be the next group in the METAR code. This is simply a 2-digit number for the air temperature, a /, followed by another 2-digit number for the dew point. These are measured in degrees Celsius. In this example, the air temperature is plus 10 degrees Celsius and the dew point is plus 2 degrees. If either are negative, they will have the prefix M. Now the dew point is minus 2 degrees Celsius. The next important feature of the METAR is QNH. The QNH will be represented by the letter Q, followed by a 4-digit number representing the actual pressure value. If the QNH is less than 1000 millibars, then the value will be preceded by a 0. For example, a QNH of 991 millibars would appear as Q0991. It is important to note, however, that none of the other pressure values will appear in a METAR, only the QNH. The QNH is always rounded down for safety reasons. The group entitled Recent Weather is used only when significant operational weather has occurred in the past hour or since the last METAR, whichever is shorter. The group always begins with RE and is included if a weather phenomenon has recently ceased or has decreased in intensity. RE actually stands for recent. If there was a thunderstorm during the hour, but by the time of the observation the rain was light, the present weather would be -RA with RETS as the recent weather group. Although not currently issued at UK airfields, wind shear information can be reported in the METAR. This will simply be denoted by the letters WS followed by the details of the report. A trend forecast is valid for 2 hours after the time of the observation and is attached to the end of the METAR. It gives the change in conditions expected. The change can be indicated either as becoming or temporarily. These may be followed by a time period in hours and minutes. However, these time periods may be preceded by from, till, or at. Let's look at an example. This trend is suggesting that temporarily from 10:20 Zulu to 12:20 Zulu, the visibility will reduce to 1,000 meters in heavy showers of rain.
If there is no change forecast, then the word no-sig is used to imply no significant change is expected in the next 2 hours.
An equal sign will appear on the METAR to denote the end of the message. A variation on the METAR is a special report. This will have the same format as a METAR, but will be denoted by the abbreviation SPECI at the very start of the message. A specific report will be issued when the weather conditions significantly change in the period between routine observations. This can be used to indicate either an improvement or deterioration in the weather. With practice, you should be able to decode METAR reports accurately and speedily. Make sure you do not just look at the METAR for your departure or destination airfields, but also at others along your route, and in particular those upwind, in order to get a better picture of the conditions that could be with you soon. Always be wary. Conditions will and do vary from what you may have interpreted from the METAR, so be cautious and assume the worst.